All right, so we're just reviewing this question which was done last week. So you already see answers that have been calculated, but I just want you to get the main concept. All right. So we have a question here. It says the table below shows the probabilities for the number of complaints received each day by a newspaper agency from customers not receiving a paper. So in this case, X, our random variable, represents the number of complaints. All right. This is 10 complaints. This is 20 complaints. This is 30 complaints. This is 40 complaints. Right. Then our bottom row, this represents the probabilities. All right. The probability that you get 20 complaints is 0.3. Remember, we can convert this also to a percentage, 30%. The probability that you get 30 complaints for not receiving a newspaper, 0.45. You can convert it to a percentage, 45%. The probability that you receive 40 complaints, 0.15, which represents 15%. All right. So the first question is find the value of K. So always remember probabilities, whenever you're totaling up probabilities, they always equal to 1. All right. And when you're finding your values for probability, all right, your answers have to be between 0 and 1. Any number above 5, above 1, that's not possible. All right. 1 represents 100%. Okay. So here they've told us find the value of K. All right. So as you can see in our solution here, all right, we said the summation of the probabilities equals 1. All right. So you're supposed to make an equation. All right. And you equate it to 1. So you say K plus 0.3 plus 0.5 plus 0.45 plus 0.15 equals 1. All right. And then you put like terms together and you find that your value for K is 0.1. Any questions before we move further? Any questions on how we found the value of K? Yes, yes. Okay, so thank you for that. Okay, so when we said, so this expression, right, what it's saying is the summation, when you add up all the probabilities, they should give you 1. Okay, so what you're going to do, you form this equation here. Okay. Then you add up these probabilities 0.3 plus 0.45 plus 0.15. When you add these three probabilities, you get 0.9. Then when I said you add like terms together, like terms, since K is a letter, so we can't conduct any operation with K. But this 0.9, we can take it over the equal sign so that we conduct a mathematical operation with it. So we take this 0.9, oops, we take this 0.9 over the equal sign. Here it was positive. Once it crosses over the equal sign, it becomes negative. That's why it's become 1 minus 0.9. All right, then 1 minus 0.9, that is 0.1. Are we okay with that, madam? Who was the one who asked on this? Are we okay with this tabulation here? Who was it who spoke? Madam Teresa? Yes, Madam Teresa, are we okay with this? Yeah, she left the meeting. Okay. Right. For those who are joining, who have just joined the class, I'm just reviewing the discrete probability distribution questions. All right. Then after that, I'm going to send you some questions now to answer for yourselves. So this is just a review of the example I did last time. Okay, so we found the value of k, it represents 0.1 or 10%. So the probability of getting 10 complaints that day is 10%, all right, or 0.1. The next question is find the probability of getting at most 20 complaints, all right? So you come to your table. When we say at most, it means 20 is the maximum number. So we'll look for any probabilities below 20. Any probability below 20 is this one here. Okay. So to tabulate the probability of getting at most 20 complaints, it also means you can also get 10 complaints, all right, or 10 or 20 complaints. We first represent it with like this, all right? Because the probability, they'll expect you to be representing these operations like this. So the probability of getting at most 20, oh, this is at least, probability of getting at most 20 complaints, all right? So there's a probability we can get 10 complaints plus there's a probability we can get 20 complaints. So the probability of getting 10 complaints, 0.1. Probability of getting 20 complaints, 0.3. You add them together, 0.1 plus 0.3, get 0.4. So there's a 40% probability that you can get at most 20 complaints from customers who haven't received newspapers. Any questions or queries, clarifications before we move further? Remember, probability is also a big topic, so I want us to move accordingly. Find the probability of getting at least 20 complaints. So you can get complaints which are more than 20, and the least number of complaints that you must get are 20 complaints. All right. So this is how you represent the probability of getting at least 20 complaints. Right. So from the table, all right, we're going to focus on the. Is that a question? Yes. This represents probability. Mhm. At most. Mhm. So at least 20 complaints, we are focusing this side. All right, so we're going to add these probabilities: 0.3, 0.45 plus 0.15. Okay, so I believe when we added these, 0.3 plus 0.45 plus 0.15, we get 0.9. So there's a 90% chance that you are going to get daily complaints of at least 20, which would be very worrying for this company. All right, it means, was this 90% meaning that these are the complaints that are going to be coming. So it's worrisome for this business. Any questions, colleagues? Let's add a bonus one. What about the probability of getting less than 30 complaints? What is the probability of getting less than 30 complaints? Can someone give us that value? Anybody? Not less than 30%. Less, the probability of getting less than 30 complaints. Why have you ignored this also, this one here? This 0.1. Yeah. So there's a 40% chance of getting at less than 30 complaints. What about greater than 20 complaints? What's the probability of getting greater than 20 complaints? Greater than 20 complaints, right? 0.45 plus 0.15, 60%. So there's a 60% chance that you get greater than 20 complaints. So if you are a business, this is not good, all right? Because you want these complaints to be as minimal as possible, all right? Yes. And I hope this is how you represent less than 30. You just do this for that one, px equals x less than 30. Then the one for greater than 20, you just flip this sign here. Okay. So always remember, include these in your operations. Don't just start adding and you don't include this. No. All right. Yes. Any questions before we move to what's the next part of the question or the expected value? Any questions, colleagues? All right. Because the question that's coming for you, it's going to be in this same context. All right. So at least we should submit correct answers. And this never misses in the past papers for ons. All right. Next is the expected value, which is the same as the mean. All right. This just gives us, it's like finding the average number of complaints, basic. All right. So whenever you hear find the expected value, you should be thinking, oh, I'm finding the mean. All right. The mean number of complaints. All right. So this is the formula for the expected value or the mean. All right. E open brackets x close bracket x, this represents expected value. right? Then sigma summation of x, the random variable, multiplied by its corresponding probability, right? So you're going to multiply the random variable x by its probability, and then you total it up, all right? So this is the operation here, okay? Let me just bring the table, just show the table. So you're going to say 10 times 0.1 plus 20 times 0.3 plus 30 times 0.45 plus 40 times 0.15. That's all that we are doing here. Are we okay with that, colleagues? We're multiplying the random variable with its probability. Then you add. Yes, I. Is that a question? Okay. Yes. So when you do that, which is represented here, 10 times 0.1, 1, plus 20 times 0.3, 6, plus 30 times 0.45, 35.5, plus 40 times 0.15, it's 6. You add this, you get 26.5. Although with complaints, you can never say that there's half a complaint. So in such cases, you round off 27 complaints because there's no such thing as a half complaint. Unless, is there anybody who knows what a half complaint is? Maybe you can shed more light. Let's, let's round it off to 27 complaints. And any questions before we move to the next part? Okay, let's go. The next thing they've told us is to find the variance, right? As I told you, there are two ways you can find the variance. You can use this method for the formula, or you can use the method for the table. Okay, you will not be penalized, right? But I find this method as more uh, time effective. Yes, is that a question? It's the average. Yes, the average number of complaints. Okay. So the next thing is the variance. So as I was saying, there are two methods. You can use this formula or you can use the table format. So if you use this method for the this formula here, what you're basically doing is the same process you used to find the expected value. The only difference is only the x values, you're squaring them. Okay. As you can see, 10 squared times 0.1 plus 20 squared times 0.3 plus 30 squared times 0.45 plus 40 squared times 0.15. Right? The same format we're using to get the expected value, only difference is we are squaring our x. the random variable. As you can see, e open brackets x squared. All right. So that's what this represents here. All right. I've even broken the formula down here to this. If you break down the formula, it comes down to this. X squared, the random variable squared, multiplied by its probability. Then you subtract. You add all of them up. Then you subtract the expected value squared. The expected value, you have to square it. Okay. So you add up the where you squared the random variable and you multiply it with its probability, its tabulation here. All right. Once you find that total value, you're going to subtract it from the squared value of the expected value. Are we okay with that, colleagues? Or maybe I should rephrase the English. Are we okay with that? Oh, let's see how I can rephrase this. Okay. Here's let me zoom into the formula here. Okay. Okay. Yes. Mr. Brighton, you'll find this formula there. Okay. If you don't find it, this is what you do. You raise your hand and you tell the invigilator that there is one formula missing here. The indiv- the invigilator is going to ask you, how sure are you that this is the formula missing? And now you have to now break down the information about discrete probability distributions. You don't have to worry. Yes, yes, yes. The table you won't find it on the list of statistical formulae. Does everyone have the list of all the formulae for statistics and probability? Do we all have it? If not, I'll share it in the group. All right. These things is just a matter of translating that Greek and understand what it's talking about. Yes. Okay. I'll send T and N family. You raised your hand. Okay. So as I was saying, I try to rephrase the English here for this formula for the variance. So what's happening here is your random variable, which is the number of complaints, you will square, and then you multiply it by its probability. Okay? You square the random variable and you multiply it by its probability, then you total the value up. That value, you are going to deduct from it the mean squared or the expected value squared. Is that okay, colleagues? The random variable, you square it and multiply it with its probability, then you total them up. This is this sigma here, totaling them up. Square the random variable, multiply by its probability, then you total them up, then subtract from the mean squared or the expected value squared. hope that's okay. So 10 squared times 0.1. 10 squared is 100. 100 times 0.1, that is 10. 20 squared is 400 times 0.3, 120. 30 squared is 900. 900 times 0.45, 405. 40 squared is 1600 times 0.15, you get 240. All right, so these values here, you have to total them up. In the meantime, we also square our expected value. Remember 26.5, we squared 26.5, you get 702.25. Then you add 10 plus 120 plus 405 plus 240, you get 775. 775 minus 702.5, you get 72.5. That is your variance. When they ask for a standard deviation, you just get the square root of the variance. Square root of 72.75, 8.5. Any questions? Okay, this is the part where now we get our papers and pens and we participate. The agency, all right, state the cost in quarter of daily complaints to be C open brackets X equals 500 plus 20X, where X is the number of complaints. Find the mean and standard deviation of the cost of daily complaints. So what is going to happen here is these X values here, we're going to be putting them in that function to get the costs of the daily complaints. Right, so here we have X, we're going to say C X equals 500 plus 20X. Right, so we're going to start replacing now. Where there's X, we'll replace 10. So if we replace 10 with X, what is our cost? What is the cost of 10 complaints? That's what we are finding here. What? So let's replace X with 10 in this function here. Where there's this X, let's put 10 here. What value are we getting? 200 plus 500? 700. So that's the cost of 10 complaints. Let's find the cost of 20 complaints. So this X here, we replace it with 20. What do we get? 900. That's the cost of 20 complaints. This 30 here, we replace it with X here. What is the cost of 30 complaints? And this 40, we replace it with x here. All right. So these are the costs of the complaints. Now you're supposed to find the expected value, the variance, and the standard deviation. So let's tabulate that, colleagues. Let's see if we've grasped the concept. So let's find the expected value first, then this is the variance, then the standard deviation. So now let's get our papers. And right now I'll just be listening to answers now. Okay. And I'll be verifying if they are correct or wrong. So the expected value AX, we're going to put insert summation of random variable multiplied by its probability. So in this case, our random variable now has become the costs of the complaint. Right. So let's find our expected value. Remember, this is mathematics, not principles of management. Yes, has anyone found the expected value? Okay, yes, what is it? Correct, 1030. I believe all of us know how that value came. What about the variance? Remember, standard deviation is how far the data points are spread around the mean. Then the variance is that distance the data points are spread around the mean. You're just squaring that distance. Yes, so the variance here's the formula that you use. Bar x e x squared minus e x squared. Meaning you're going to get the total figure when you get the total figure of the when you multiply the our random variable x, when you square our random variable x and you multiply it with its probability, then you would subtract that total value from the mean when you square it. If you're not sure what to do, consult. This is not a test or anything. We're just solving a question together. So if you're not clear on something, consult. In the meantime, as you are solving that, let me just put the workings here so that we can study well. Have we managed to find the variance? Yes, what is it? 99, no. Oh, wait. I never finished my tabulation. Let me just confirm. Okay, so 1,090,000. 29,100. Correct. Colleagues, have we got this? Are we all getting this figure? All right, the standard deviation, how spread out the data is from the mean. A low standard deviation, it means that the data is closely packed, all right, closely packed around the mean. A high value, the higher the standard deviation, it means the further the data is spread around the mean. So what is so we get the square root of 29,100. What is the square root of 29,100? One 170. Okay, that can indicate that the data points are near the mean. They're not really that spread out. Just looking for the square root sign. Where do you put the square sign? Okay. 29,100. What did you say God again, Mr. Tapiwa? 0.5. All right.